All right, so it's been a long road. It feels like we've been here for months, but actually it's only been a couple of days. The weather outside is beautiful, I think, but I wouldn't know. This is, as promised, the follow-on to the session that I started Monday. So I threatened you on Monday that I would be back on Wednesday, and true to my word, here I am. And the session that we did on Monday was called Evolving OFS, and it was about, from the tops down. And I talked about what happens to sharks when they stop swimming. So I chose to title this one, Teaching the Sharks How to Swim from the Tops Down. What happened was I started with an idea of what I wanted to do on Monday, and then promised that I would listen, as I asked all of you to do, very carefully to the sessions that were presented Monday, Tuesday, and Wednesday morning, and then try to summarize the results of what was going to come out of that in these slides here. And we put these charts up on the wall that I'm really gratified to see that some people added things to. And I got to sort of an unexpected result. And you'll see what that unexpected result was in just a minute. And the net result was to create more work for Tom and Diego, so I've been successful. I created more work for somebody else. The objectives, just to level set on this, there shouldn't be any controversy about this at all, but the way I see the objectives for the Open Fabrics Alliance, the premier provider of I/O software for HPC, we can take it done on that more or less, but if we don't keep moving, the sharks are going to die, so we got to keep going. And the premier provider of I/O software for everything else. So that's the other thing that we also want to do. And I spent most of my talk on Monday trying to convince you that if we looked at three broad categories of places where we could improve, that we would accomplish those goals. And those three broad categories were scalability, usability, the way that users use the system, and to incorporate technology. And if we accounted for all those things and allowed Open Fabric software to evolve in response to those things, that we would be live sharks and we would keep moving, and I/O would be good, and we continue to lead in I/O technology, which is our fundamental goal. I wanted to build on a concept and amplify a concept that Bill Magro had introduced in his talk on Monday. He talked about this notion of application-centric I/O. And just to elaborate a little bit, it's application-centric versus what I would call platform-centric. So to me, what separates Open Fabrics from any other I/O or interconnect technology is that it really focuses on what the needs of the application are first and foremost, and then how you get that I/O to happen is really a secondary issue. That's in contrast with other networking technologies where it's really about how two platforms are connected together and how bits move across the wire from one platform to the other. We really take a very application-centric view. So I'm just going to read the words because I think they may be helpful. But the point behind an application-centric I/O is really to allow applications to communicate with each other and to do so in an interoperable way using industry-standard wire protocols. That's what we're about. The industry-standard wire protocols are provided for us by an industry standards body, for example, the InfiniBand Trade Association or some other industry-standard body. So the name, this notion of application-centric I/O, really comes from the fact that the entire I/O infrastructure is derived by looking at the requirement of the application. And this is fundamental. This is where I think we're trying to drive OFA going forward. And this is the heart of what I think, I'm going to paraphrase Bill, he wanted us to do was look at what applications need and then gen up the appropriate I/O stack to meet the needs of those applications going forward. The method for accomplishing this communication between applications is to allow applications to directly access each other's memory. It seems obvious, but that's what we're really doing in OFS. There are all sorts of mechanisms built in that allow one application to directly access the memory in another application's virtual memory space without using the OS and in a very low latency, very high bandwidth way. So the fundamental method here for accomplishing our goal is about memory-to-memory transfers. So let me give us, I won't even call this a definition because a definition is way too strong a word. Let me call it a description. And here's where I'm going to ask you to stretch your thinking just a little bit. I'm going to play a little quick game with you. If I say the word RDMA, what's the very first thing that comes to your mind? Anybody?
IB.
IB. That's what most people say. It's IB, it's InfiniBand. I'm going to try to stretch us just a little bit and get us to think about RDMA as a communications model and InfiniBand as an implementation of that communications model. And you'll see why in a minute. It's going to be helpful for us moving forward, I think, to think of it that way. But in any case, RDMA, the way I've described it here, really is the playground within which OFA plays today. Now, that's not to say that we can't go find another playground if we need to or want to, but today, that's the playground that we're in. So, if that's really true, that what we're trying to do is to communicate between memory spaces, applications memory spaces, that's that top thing. At the very highest level, that's what we're trying to do. That's our goal, is remote memory access. And then the next level down is a little bit less abstract and a little bit more open to interpretation, which is that we do it via message passing. That's the method that we use today, primarily speaking. And the reason I say that, and it's a little bit controversial, and we don't need to get wrapped around the axle on the details of the semantics, but the reason I say that is because the InfiniBand architecture, for example, has a lot of constructs built into it that will allow it to define the boundaries of a message, and that's what's passed to an application. It's not a stream of bytes. It's not a nondescript buffer. It is a specific message. That's the goal. That's what Open Fabrics is built on today, is this notion of memory-to-memory communications largely based on message passing. Below that is the verbs as an interface and a whole bunch of IB-specific mechanisms to allow those top two things to occur, and a set of wire protocols to support it. So the way I would look at this is, the objective is the stuff at the top. This is what I'm going to try to convince us all RDMA means. And then the stuff at the bottom is the mechanisms by which we conduct RDMA operations today. Now, please don't get too wrapped around the axle about this. You know, the word RDMA, or the acronym RDMA, is so overloaded by now. It started out meaning one thing as defined in InfiniBand. The definition was changed with the development of iWarp, and I'm suggesting a more abstract view. Maybe I should have come up with a different acronym, but I didn't. So really, this is what the OFA really cares about. We really care about being able to move messages between one application and another in the most direct, low latency way possible. And again, I'm going to point at Bill Magro, who gave us a number of characteristics of what that interconnect would look like. It was low latency, it's high bandwidth, but fundamentally, it's the ability to move messages from one application space to another without involving the OS to do so, in a stack bypassy kind of way. And to do that, we're living with what we've been given today by the InfiniBand Trade Association. And that sounds slightly pejorative, and it's not intended to be that way at all. That's the world we're living in today. Let me talk for just a minute about what the role of standards in all this is, because as an open source organization building open source software that lives on top of a standard, it's really, really, really helpful, and I would say crucial, that we clearly understand where the delineation is between what open source can do and where some change may be required in an open standard. So let me just read the words here, because I think they're really kind of important. So the IB/Rocky/iWarp standard, so there's a clue right there, right off the bat. When I say InfiniBand, it means all of those things in parentheses. The set of mechanisms that are used to move messages over a wire, whether they're provided by InfiniBand or by Rocky or by iWarp, is incidental and unimportant. The point is that there is a standard that moves messages. It could be one of those three, and it could be some other that we haven't seen yet. But the standard governs the mechanism for transporting messages and the format and layout of the packets comprising the message as they appear on the wire. That's what a standard does to us. Whenever something shows up on the wire, that is governed by the standard. That is the relevance of the standards to us as the Open Fabrics Alliance. So if we choose to do something in pursuit of remote memory access and/or message passing that's going to impact the way that packets appear on the wire, it suddenly becomes an issue for the standards body to get involved. It's beyond what we as an organization, open standards body, and open source body can do by ourselves. It's a very important distinction. It's obvious. There's no one in this room who doesn't know this. I just wanted to highlight it so we're all clear on the difference between what is open source software and what is a standard, and where the two intersect. So with that background, let me back up to the early days of the Open Fabrics Alliance and what used to be called OpenIB. And this picture is sort of what I would call an idealized version of OpenIB. You know, at the time, the hope was, and no one believed that this was actually the case, by the way, but sort of the idealized hope was that applications would all be written directly to the Verbs API, and that OpenIB would provide the Verbs API. The whole idea about OpenIB was it took advantage of the verbs definition that was created in the IB spec. So again, there's an important subtlety here. The IB specification creates or contains within it a semantic description of the verbs. So this word verbs gets overloaded. There's the Verbs API that you all know because you've written those Verbs API. But then there is the verbs semantic description, which is specified in the IB spec. I want to make a distinction between those two because it has to do with the interface between where Open Fabrics is and where the standards bodies beneath us are. Messages were carried in packets according to a standardized wire protocol. So that was OpenIB as we first knew it. The reality turns out to be just a little bit different. There are, in fact, idealized applications that are written directly to the Verbs interface, and with any luck there will be more as time goes on. The Verbs interface is the right interface for the message passing protocol that we're using today. There are also a large number of legacy applications that are never going to be and should not be rewritten to the Verbs interface, and for that purpose a series of ULPs were created, and you heard about two of those ULPs in the past couple days, one being RSockets and the other being SMCR. And there's a number of others. SRP is in that category. We used to have something called SDP, and there's a few others. There's another application, or I should say class of applications, MPI, that was initially written directly to the Verbs interface, successfully, I might add. And then there's this other one that there is a path through it today, but it's not very well defined, and it's where I think we need to be focusing, as you'll see in a minute, for PGAS languages. So PGAS languages, compilers never are written to the Verbs interface. It's not practical to ask a compiler writer to do that. So there's a series of layers in there, and we talked a little bit about that in our PGAS panel on Monday. So that's the reality of where what we have today. So our goal as an organization, and the reason that we're holding this workshop this week, is to achieve this goal right here. We need to figure out how to optimize and extend this architecture. Notice I didn't say we need to find out how to trash this architecture and start over. That's not what we're doing at all. We want to build on what we've got. We want to keep it moving forward because we fundamentally believe that those two things at the top are the basic right approach for us. For now. We may find other approaches, but for now, that's the right approach. So how do we extend the architecture that we've got? How do we work the relationship between the OFA and the standards bodies beneath us to accomplish the goals that we're shooting for, which is basically to provide the best possible I/O services that we can to the classes of applications that we support. That's what we're trying to do. So let's take a look at MPI, for example, because the way that the path that we followed in optimizing MPI, originally written to the Verbs interface, is, I think, somewhat instructive. As I said, it was originally written to the Verbs interface, but over time it was thought that, and here's where I think the slide is probably not right. It should not say is too heavyweight, because it's not. But what was pointed out, or has been pointed out a number of times, is that verbs are thought to be a poor match for MPI. So as we looked at the needs of an MPI-based application, we discovered, you know, it's really not the greatest match for the verbs. And for whatever reason, the Open Fabrics Alliance concluded that we needed to address that problem. The solution to that turned out to be the introduction of a thing called PSM, which is an acronym that I don't actually even know what it stands for. But it reflects the fact that there is this sort of fundamental mismatch between MPI and verbs. PSM addressed this mismatch, but it did it in a very vendor-specific way, which is not a bad thing, but maybe not exactly what we want. What we as Open Fabrics would really like is an interface that supports MPI that is vendor neutral and transport neutral in the most general way that we can. So we may want to take a look at another swing at how do we best support MPI applications, hence the request. So this is the format I'm going to use here on out. There's going to be a request for something to happen. In the 3-column chart over there on the top, that middle column was the ask. What are we asking someone to do? Request is the ask. This is what we're asking for. So somehow we'd like to solve this problem in a vendor-neutral way. And we'll come back in just a minute and address the 3rd column on the chart, which is who is the askee? In other words, who are we asking to do something about this? And I'll talk about who that is in this case. But I think the MPI case is illustrative. We want to optimize MPI. We want to solve the problem that PSM solved, but we would like to do it in a vendor-neutral way, and that's the request. Similarly with PGAS, we really want to do the best job that we can with supporting PGAS. The difference is, well, I won't say that. So the request is, and there's actually 3 of them that you can see here, and they're sort of interlocking. The top one is to consult with compiler writers to innovate at the layer of what I would call the interface. In this case, it happens to be GasNet, but the panel told us quite clearly that we need to have a healthy discussion about what the right interface is, or interfaces. It may not be just one. There are those who strongly believe that GasNet is a great idea, and those who just as strongly believe it's not, and something else is. We need to have that discussion, and the way we're going to have that discussion is by consulting with whoever it is that owns that application, the user. And in this case, the user is the compiler writer who's writing a PGAS compiler. He's the guy who can tell us what he needs the I/O infrastructure to do for him in order to implement PGAS. That's the first ask. The second is, once we've done that, we understand what that top-level interface looks like, we need to choose the correct set of, in PGAS terminology, conduits that are used to conduct that upper layer extended API down to the wire itself. So what are those conduits? Presumably one of them is GasNet straight to the verbs, I would imagine, or whatever that upper layer extended API happens to be. So chosen based on the upper level interface, we need to choose the correct conduit and implement it. Those are two asks. The third one is, we may find out as a process of doing that there are things that we would like to do that the verbs API doesn't do well, and we want to improve the verbs API. We may want to engage our fellow standards bodies at that case in a discussion about what is the right quality of the API and how does that get reflected. So you can see it's sort of a building block approach from the top down. Again, I'm trying to be very consistent with Bill Magro's suggestion that we innovate here in Open Fabrics Alliance and then try to drive change down through it. Now I want to be clear. This does not mean that the Open Fabrics Alliance goes to the IBTA and says, you need to change the verb's behavior and here's how you're going to change it. Instead, what we do is we go to the InfiniBand Trade Association. We say, here's the API that we've come up with. Can you help us figure out, or can you figure out, based on that, what is the right semantic behavior that needs to be captured in the spec, and how is that reflected on the wire? That's an IBTA problem. That is not an Open Fabrics Alliance problem. Again, I'm trying to be very, very clear about what we do, what IBTA does, and where the intersection between them lies. This leads me to what I would call a general model for extending OFS going forward. How are we going to drive OFS into the future? And here's where I'm choosing to try to give Diego and Tom Statura as big an AR as I possibly can. So the method generally is to consult with the application class users and innovate. This was Bill's call, and I strongly support it. The next was, where practical, we should write the ULPs to the verb interface. And let me tell you, I think where practical is virtually all of the time. If you think that you're going to need some other interface than verbs, you're going to have to make a really, really strong case for it. And that case has been made in at least one case before, and it could be made again. The version of the slides that is supposed to be up here, but unfortunately I somehow lost them in translation, showed that little red arrow, that little arrow from the ULP straight to the provider as red. And that's why. Because that's a higher hurdle. Simply because we are so much invested right now in the verbs interface. Before we allow the number of interfaces that we support to proliferate and explode, there needs to be a good reason for doing it. Once we figured out what the ULP is, what the ULP is and the interface that the ULP is going to use, then we need to work with the standards bodies to define what the provider and NIC are as needed. And again, our role is to describe to the standards body what the API looks like as we see it, and then it's the standards body's role to figure out what the provider and the wire protocol looks like to support that. So this is the general model that I think we're going to try to drive towards, or at least I'm recommending we drive towards. So let me give a couple examples how this might work. Here's one example here. So suppose we wanted to add support for big data or some other class of applications. We're going to spend some time talking to whoever the owner of that application class is. And we had some people from the big data world in here during this workshop, and that discussion will continue. So if you are an OFA member and you would like to do the right thing to support big data, you're going to spend some time engaging with people who are trying to implement big data type solutions, and you're going to try to define what you think are the right interfaces that big data is going to use to take advantage of the I/O services that we provide. And the result of that is that the OFA is asked to do something. So the request here is add support for big data or some other class of application. Again, just an example. And the owner of that is the Open Fabrics Alliance. Here's another example. Figure out what we do with deploying NVM. So again, this just involves us in the Open Fabrics Alliance. We can deal with this in-house. At least it looks that way right now. May change. As we dig through this and figure out what it means to deploy NVM, we may discover that it requires interaction with a standards body. Maybe yes, maybe no, I don't know. But for now, let's just assume that. Just an example. By the way, the correct version of the slides that we're supposed to be looking for has in big red letters across the bottom, illustrative example. I don't want anybody to be taking, this as a call to action on these specific items. These are just illustrative examples of how I think we're going to proceed going forward. Another example here, what about lightening the verbs interface? This one kind of falls in the cracks right in the middle, and it's because we own the verbs API, but the IBTA owns the verbs semantic definition. So we may say, we'd like to lighten the verbs API. And so we'll go through and do a code analysis and try to shorten code paths and do the best we can. But ultimately, we may come to the conclusion, this would be better if the semantic behavior was different. And at that point, we might engage the IBTA and say, let's think about changing the spec for that particular verb semantic. Here's an example of where it falls in the crack between us. Here's another example. What about reducing memory footprint by creating what I would call reliable connectionless service? We already heard a presentation today about how that might be done. The call to action in this case, again, just an illustrative example, but were we to pursue this, it would be take that into the IBTA and standardize that mechanism. Same thing for reducing the cost of memory registration. This is something that would be done in the IBTA, but it's going to move us forward because it's going to make the I/O stack that we provide that much more efficient, that faster, and that much more able to support the applications of interest to us. Here's one that came up in the presentation just last night from Wham Cloud. Doug stood here and said, boy, if someone would just add channel bonding. And I thought, well, there's a good example right there. So let's take that on as a task to get that done. Do we do that here in the OFA? I don't think so, but I'm not sure. But the TAC needs to go take a look at that and decide if it's something that's done here in the OFA or if it really needs to be brought up to the IBTA and it's done in the IBTA. I'm not sure how it's done. Maybe it's done in software. We need to work that out. Now I am going to spend just a second to go find the right slides because there's a wrap-up that you really do need to see. So let me just take a brief breather. You can digest everything that I said and decide you hate it while I'm doing that. Here we go. Okay, we're even on pretty much the right slide. How cool is that? No, it looks like I managed to lose the stuff I wanted to say. There was a nice little picture that shows there's really 3 categories, but you've seen that. So that's my proposal Boy, I'm really sorry I missed that, because there's a whole other thing that says this is what I'd like the TAC to do. So it assigns the AR to the TAC itself to go off and do this. So this is the proposal, and I'd like to open the floor to some discussion, and then I'd like to invite Jim Ryan to come up and comment on this as well, and possibly Tom and Diego, if they're of a mind, to join me on stage and comment on this as a mechanism for moving open fabrics forward.
I have the right one if you want it.
Do you? Actually, I do too. It's right here in my... Can I plug this thing in, Rupert?
Sure.
Where's the USB port?
Yeah, that'll do it. Just kill this thing first. Get some of this junk out of the way.
So how do I get to it? I need to go here and look at computer.
Yeah, right there.
That's too easy.
Sometimes it takes a second to come up. Removable disk. No, we're just searching. We've had about 20 revisions of this presentation. We're just trying to figure out which is the right one. Actually, we're going to see if we can get that video again and play the music in the video.
All right, so here is the right one. Let me just point out the places where it changed. Nothing real different there. Just a little bit different view. Oh, I did have this notion of, again, trying to motivate the idea of application-centric I/O, but anyway, not really important. Saw that. And change there. Yeah, our goal here is teaching sharks to swim. No big change there. All the same stuff. There it is. So there really are three categories of ownership, and the examples I gave made that clear. One is things we can do in the OFA, one is things that the standards bodies have to do independently, and one is this overlap or gray area. As someone, I think it may have been Diego, pointed out to me, in management training, whenever you have joint ownership, that means nothing. Nothing happens. So I hope that isn't the case, but be aware. There's now illustrative example, so there's my qualifier, so now you know. I'm not assigning ARs to anybody here, I'm just trying to convey a concept. And I've used the terminology I said I would use, a request and an owner. That's what we said we were going to do with the charts. Identify a challenge that needed to be met, what we're asking for, and who the askee is, who we want to do something about it. Okay, so here it is, the proposal. The OFA's Technical Advisory Council to own the process for the OFA. And the other disclaimer is, obviously, code is not created by the OFA. There is no OFA that writes code. The OFA is the sum of its member companies who choose to write code and submit it to open source. So I just wanted to be clear about that. You all know that, just so you know that I know that too. So, discussion. Christoph, please.
Well, I'm a Linux core developer, and I kind of have a different view of things. My challenge is to get OS bypass going and direct access to devices and user space. I think that's the main challenge that I want to solve, and the RDMA APIs are useful for me for that purpose. And the InfiniBand is some kind of a communication between various nodes, but I think the main challenge there is to get into the caches of the various cores in the future. And so I think that this is all a bit out of whack for me, and I'm not sure that I identify with the goals that you've proposed here, and I certainly don't think that the stakeholders here have too much to say in that, because I think since with the system, the Linux developers determined the system call API, I think we are going to come up with an API that allow easy offload, and that will be the standard for the future. And so kind of, I'm not quite sure that this will have mainstream relevancy here.
There's another layer that I didn't mention that we can't do anything about because it's completely out of our purview, but how data gets into the cache and when has nothing to do with anything that we can control. That's entirely up to the vendor of the memory controller. So for that reason, as much as that's your goal, and I agree with it, the best we can do is say, we want it in memory. Now, if the processor does the right thing and caches it on its way to memory, life is good. So that's the relationship.
Well, the Internet already has PCI control headers where you can configure the caching behavior for incoming packets. And that is pretty important for a reduction of latency in the future, I would think. And given that we will have multiple cores and massive amount of cores in the processor, the targeting of the traffic to the correct cache becomes very important.
Right.
So I think that it's a very valid request, and I think that actually fits along the lines of some of the things that Paul was mentioning. This is a different type of semantic enhancements that you're talking about. Specifically what you're saying could potentially be addressed by making a richer memory registration API, whereby when you create the memory region, you specify and allow control from above the API to some of these new elements that exist today in the way this fast I/O devices access memory, and that I think fits within the model and process that Paul was describing. Maybe it's not oriented to your typical RDMA application the way we used to talk in this context, but maybe that addresses your needs.
I just want to say that I totally support, your idea here. Mm-hmm. I think it's the right way to go. I think at least it warrants some exploration and some prototyping, and I have a lot of people that work for me, and maybe I can provide some resources to help with it when time comes.
Thank you. Other comments? If not, I'm going to make Jim Ryan come up and comment.
I'll make a quick comment, Paul.
Please.
If you go back to your diagram where you showed MPI and I think PSM or something, right? That one. One thing I struggled with when I used to draw software stacks was separating the implementation from the interface. I always found that if you try to make these diagrams, you can get confused about what's the implementation, what's the interface.
Yes.
And I think what we would benefit from is an MPI-friendly interface that lives at the verbs level in that stack. And then an implementation of those that targets something lower. And today we target verbs. That's what an MPI implementation is. And we pick up some inefficiencies, and we talked about that. PSM implemented MPI-friendly, an MPI-friendly API, but by going to a lower level, which was a hardware-specific interface to put packets on the wire. So now to my point. What if all the vendors, this doesn't have to be standard, actually opened up an interface that was hardware specific to put packets on the wire? That would create a sandbox for software people to do protocol development and play around with the ideas, see what was feasible. And then once we proved the APIs were valuable to the consumers, we proved that we could come up with flows that worked, then that could be input to standards bodies to go think about standardizing them and getting the interoperability.
That's exactly the process that I'm hoping that we're going to follow. Notice that I was very generic in my suggestion here, which was the request from the OFA is to go off and solve this problem in a vendor-neutral way. And you just proposed one way to do that. So my response would be, let the conversation begin.
Yeah, but there was a specific addition I made, which is if we can find an easy way to get at the low-level interface and inject some packets, we can start doing some interesting things. We know how to do that on the Ethernet side today, and at least inside Intel, when we prototype these protocols, we do it in Woody's team, we do it over Ethernet because it's easy to inject packets at that level. What if we had access to packet level control over fast fabrics? That might be more powerful.
Which would require the hardware vendors to agree that's the right answer. And if we can get them lined up, great.
Yeah, I don't think it's required, but I think it would accelerate the process. That was the point.
Diego?
Oh, no. I wasn't going to say.
Well, we have mechanisms in the kernel also to direct flows to various processes right now with the RSS receive flow steering and stuff like that. So I would think that this would have to be consolidated and merged with that, and that we need to come up with a way that works throughout the Linux kernel in order to direct flows. And that goes back to the cache affinity things that I said before with the, for the network protocols.
So, Christoph, I have a request for you. You need to communicate that in terms of what it is you would like to see to the TAC. And then we'll figure out how to make that, because that's exactly what I'm suggesting we do here. You have a suggestion about the way to do things, by all means, let's pursue it. Let's figure out how to use this process to get that implemented.
The problem is also, I disagree with the owner. The owner is the maintenance of the Linux kernel. It's not your decision to make.
That's true.
It comes out on how we're going to shape these mechanisms. So ultimately, this has to fall in line with the kernel network stack and how we handle the packages.
Yeah, there are limits to what we can do.
So just two quick comments on while you have this slide up. First, PSM was a great step forward in terms of supporting the MPI semantics. It still has some shortcomings. It made a couple of assumptions, one of which is So I wanted, I guess, it has some shortcomings, one of which is ability to provide strong progress. Some of that's a design goal, a lot of it's there intentionally. It makes sense given the time, but please, the takeaway message should be PSM was a good starting point, but even talking to MPI people, you'll find there's a lot of places it still needs work. So if you're going to continue working on optimizing for MPI, please don't think you're done because PSM is there. The second is that if you look at the roadmaps for people who are using MPI and using PGAS, they are not two separate things that are going to evolve in isolation to each other. And so they're going to be commingled. They're going to be commingled in the same application. And this again drives you to PSM is a very nice interface for MPI. It is a terrible interface for interoperating with other upper layer protocols. And so again, when you're looking at this slide and the next slide, they should really almost be the same slide in that there are two things that are going to have to evolve together.
Actually, they are very much the same slide.
Yes, they are. But in terms of, don't think of it as a conduit and an MPI thing. That whatever PGAS consumer, whatever you come up with for PGAS, that consumer is going to have to interoperate very nicely with MPI. There are some great papers out there on why this is really hard today, and what they all boil down to is the interfaces underneath them suck in terms of providing progress. And I know that everyone in this room is now thinking, okay, well, RDMA provides progress, right? You just fire off the put and it shows up on the other side. That's not the progress we mean. We mean the progress for the upper layer semantics. And so, again, it's a request to, when you're thinking about those two slides, think about them together, not as two separate things that should independently evolve.
So on behalf of people who can do something about this, of which I am not one, I'd be happy to take that AR. Tom, did you hear the AR I just took for you? That's great. I mean, that's exactly what we're looking for. What is it that the application needs? Not what can we do in the wire. What does it need? And you just gave us some very good guidance about the relationship of PGAS and MPI. Well taken. Any other last comments before I vacate the stage here? It's getting late, so I don't want to drag this out much longer.
Paul, what about Ken? You want to get his feedback?
I'm sorry?
Ken Buttle, Grass Valley?
Yeah, what I wanted to point out was that what you've done is I'm going to give you the same AR that I gave Christoph. You gave us some great areas to work on. We need to figure out how to use the process to implement those. And the way to do that is going to be, let's engage the TAC to vet these things and figure out how to get them done. So that was exactly why I put the charts up, and I thank you very much for adding those comments, because it made the point very clearly. That's exactly what I was trying to get to.
Well, as long as we be clearly enough, for streaming especially, the knowledge, the understanding of streaming.
Yeah.
But I know that, we want to still consider within the construct for the OFA, and that we're passing messages memory to memory, but in this case, let's say we don't frame a video by passing messages, like computing bits, like doing pixel manipulations and throwing them at a remote where we fill a frame with video. When we do it all again, the next frame. And so it does become streamed.
Yeah.
And so I know that things like GPUs and all that, they do for copy and things like that. They typically work on a latency of one frame, frame boundaries, 33 millisecond frames. Whereas in live broadcast, we need a lot lower latencies. So that's why we have to think about things as streams. Within that stream, we have to get stuff done as the bits are flying through. And so that's why I have to bring that up.
No, it's a really good one, and I appreciate that. And I think that's exactly what we'll use this as a test case to see if this model works.
Yeah, that's great. Okay.
All right, I'm going to stop us here because it's getting late and people want to go eat lunch. But I do want Jim to take the stage here for a minute and comment. Do you want this?
This may be self-congratulatory, but we think this is one of the more important sessions. So, Billy, I know you're trying to keep us on time, but we may have to agree to run a touch over. I'll try to get some guidance from you as to how patient you are with this. Because, Ken, we may well want to come back to your point and sort of run it up against this thing and see how well it fits. That could be interesting, but that will take some time. I was one of the people that were fortunate to collaborate with Paul in the process of doing this. As you know, this is essentially a real-time presentation because Paul wanted to cram as much learning as possible from each of these sessions into the recommendations that came out of this. And I guess I want to reinforce something that Paul said earlier. We thought we'd have a bunch of bullet points to shoot off in different directions of fix this and fix that, because that's what we heard at the workshop. And certainly we did hear them, and we won't forget them. But what was more important that we concluded, I think, was the process. How do we want to act moving forward? And you sort of heard Paul describe it. All that I have done in 3 slides is say, this is what I think I heard, and translate that into some specifics with respect to open fabrics. And I did this for my own sanity and to make sure that what we're talking about here really is the right thing to do, the right new steps to initiate, the new responsibilities to take on. I hope I got it right. I'm not certain that I did, but I think collectively we can make sure that we did get the message right. So, nothing here should be a surprise. This draws directly from what you just heard from Paul. It's just from Paul's lips to my ears and written down so we can take it home and do it. The first thing is you saw Paul define RDMA earlier, and he took some pains to define that as broadly as possible. And he made the specific statement that there's kind of RDMA up here, and then there's an implementation of RDMA in the form of InfiniBand down here. So what we're asking you all to do is to buy into the broadest definition of RDMA as we practically can. What we're trying to say is there's value in focus. And by taking on a focus on RDMA, defined broadly, there's benefit. At the same time, there's every chance we're going to get it wrong. We're going to discover something down the road that's interesting, and we're going to have to go back and test some of our first principles and possibly adjust. So that's why you see me artfully talking out of both sides of my mouth. I think we can focus on RDMA. It has to be a broad definition of RDMA, and if we're wrong, we have to adjust. So that's what the first 2 bullets say. The third bullet is simply echoing what Paul said before. I think the best place to do this is within the TAC, and I've talked to now Tom and Diego, and they accept that responsibility, and that's terrific. I think it really needs a group of that caliber to do this process responsibly. I can take questions on individual slides, or I'll go through the 3 and come back, whatever sounds best to you. I think a lot of this is about leadership, and I think that in terms of leadership, this is evidenced really in 3 areas. Excuse me. The first is in cases where we can develop what Bill Magro called earlier, app-centric APIs. And I think that that is what we need to do. I think we can do it. I think there's lots of benefit in this form of innovation. And I think we have to do a better job of crafting the ask to the IBTA or other relevant standards organizations. It's not like we've never done this before. There's lots of informal communication between OFA and IBTA, for example. Many of us belong to both. You know, we really do communicate fairly well, but I think there's a better job we can do here of understanding the problems, understanding when they're within our domain and when they aren't, and we have to go someplace else. Again, reference Paul's charts. He was very clear about when it's in the top area, bottom area, or that awful area in the middle. We did spend some time in the course of doing this work of trying to understand where there were some apparent problems, for example, in scalability, other areas that were reported to us, and we now understand very well. At first, we had tried to think carefully, Paul and I and a few others. Is this within the spec and it's a fairly straightforward extension? Does this require what at one point dangerously called IB 2.0? And in the end we said, we're trying to do too much. Our best effort is to be clear on what the problem statement is and leave it to the guys that own the spec to figure out if it fits within the spec or it doesn't. So we're not going to try to make that distinction anymore. We're simply going to define things that we think need addressing and simply put them to the IBTA for whatever action they feel is appropriate. And again, I keep wanting to say, we think we can do this in an RDMA domain. If we're wrong and things come up that are a surprise, we simply have to understand that and revisit, basically this model. So in my opinion, this is a broader range of responsibilities than we've had in the past. I think we have a need to lead. Again, this is in the area of API development and also in a more aggressive and proactive request for spec development. And again, we have to be cautious that if there is something that's beyond RDMA, that we're open to it and we understand what it means. And I also want to be clear that we're not talking about sort of an arbitrary process. We're not inviting chaos. We're asking for the TAC to administer this process, make sure it's methodical and thoughtful, but we also aren't, sort of afraid to step up to the bar and do what needs to be done. So this is my best understanding. If you heard something different from what Paul was saying, then maybe I missed it and you got it. If you're okay with this, then we're done and I won't belabor it. But this is, as best I can tell, the prescription for what we have to follow within Open Fabrics. Okay, perhaps I got it right. Is it worth a few minutes to do a test of some of Ken's concerns against this? Would you find that instructive?
Sure.
Can you do it from where you are, Ken? Do you want to come up here?
Well, I can, well...
We can pass you the microphone.
No, that's okay. I'll just talk about it.
Well, no, we need you on the...
Oh.
Can you help out to make sure that we do talk it through? And he's going to tell us some things I think we need to make sure we understand where it is at the end.
Oh, thanks. Okay, yeah, I guess I just wrote some challenges down on the sheet over there, but one of the first ones is fundamentally it relates to streaming of media. And I know, as I mentioned before, message passing is what the OFA is all about. I mean, it's what the OFA does from memory to memory. If we can consider it going a step further and doing message passing from process to process across the fabric, then it serves to reduce the latency further for things like stream or media processing. And so what I was trying to get at with the one which was constructs for isochronous media streaming on InfiniBand was one where we're not trying to say, okay, well, yes, you can emulate a stream flow by sending chunks of data. You can send messages from one point to another. But it's just more a meeting out of the flow. It's more of a regulated transmission, regulated flow. It's isochronous because you might have other endpoints that are also trying to feed media into that fabric as well from endpoint to endpoint. And so the regulation of that flow becomes very important because you're passing from memory to memory, but in this case the memories may be very, very small. They may be FIFOs. They may be circular buffers in CPU memory. They may be physical FIFOs built in an FPGA or some other construct, but they may be very small. So it's treated more like a stream where you're working on the pixel level on this data as it's being passed from one point to another. I should mention as well that 802.1 IEEE has got a 802.1 AVB, they call it, audio video bridging, which is kind of trying to create within Ethernet networks the concept of streaming, of a talker and a listener, and the rate of flow, and other constructs that guarantee a quality of service and a level of capability that recognizes streams, and and has bounded latency. I mean, these are things that InfiniBand or other networks that the OFED is really geared for doing, and so that's why if you look at this AVB work that's being done in 802.1,
QAV, the precision time protocols that are also used to synchronize all the nodes that are attached to the fabric. All that work is, it's not a huge industry. I mean, broadcast isn't huge, or media processing is not a huge industry, but it is very viable. It is a very important need, and there may even be other applications other than media which require that kind of isochronous flow. So that was the first challenge that I was looking at. The second one was, given that you have these streams flowing around, in video there's a concept of a router. Now, not in the network terms, we all know what a router is, but a video router is effectively like a network switch, if you will, which controls the flow of video from video channels from one point to another, or one point to many other points. So multicast becomes a very big issue here. And multicast handling, it's not just creating multicast groups and creating source to endpoints connection, but it's also being able to switch sources as well, and switch them quickly. You've got to be able to switch and say, within a frame time, which is 33 milliseconds, you've got to be able to bring a new video in and bring it in on a frame boundary without any disturbance to the end viewer. And so that's a circuit switched application. So what we're really talking about, are we talking about applying circuit switched properties or circuit switched elements to a packet switch network? Well, I guess we are. So that's kind of what we're looking at with routing. But this is routing also with quick change as well. We need to be able to change the the joining and leaving of groups at a very rapid rate, and be able to do so, let's say, 60 times in a frame period. We have to be able to handle 60 different route changes in a frame period in larger networks. In this case, we're talking about routers where there are, say, 2,000 input streams and 2,000 to 4,000 output streams. And each of these streams is 3 gigabits per second, full HD video. So, and the rates are getting faster too, as you may have heard. I think it was Tom Coughlin talked about on Monday. He was talking about 4K video, which is 12 gigabits per second. So anyway, that summarizes what I was trying to say. Thanks very much for your time, and I appreciate you giving the time.
So Ken, if you don't go away.
Oh, okay.
If you don't mind me asking, I think what you've just done is described at least some of the requirements for a class of applications that I would call media streaming, right?
Yep.
Are you able to articulate, don't do it now, I'm just asking if you think you could. Do you think you could articulate what the solutions to the requirements or the way to address the requirements you just articulated? Could you articulate that?
Yes.
Or is that going to require further research?
Well, I think that there's more research required. I could articulate them from the point of view of a broadcast video provider. Someone who has to build the equipment and set up the systems that do broadcast video, live broadcast, not pre-canned or pre-rolled.
So you have a sense for the list of things you'd like to see changed?
Yeah.
Okay.
Been looking at this for a while.
Because I think that's the input into the process that we're looking for. Okay, thank you. That was incredibly helpful.
Thank you.